Right, now this particular cat has a pentagonal basket. It's a regular pentagon, which means all the internal angles are the same and all the side lengths are the same. So my temptation might initially be to work out the internal angles of this shaded shape. Might not be a bad thing, but because I'm looking for area, I really want to deal with triangles if I can, or rectangles. Now, rectangles won't work here because we don't really have rectangles, but we certainly have potential triangles. And because it is regular, if I put a dot here at the center of this, what I can do is create a single triangle here. Now this will be an isosceles triangle because it's the same distance from the center to the outside, which means if I drop a line down there, I will end up the right angle at that point. And I can play with some lengths here. Right? So here's a triangle that I'm looking at the moment, and I'm just going to put it vertically so I can see it properly. I know the base of this right angle triangle here is 14 because it's half of the 28 there. I can calculate that the total angle from there to there will be 1/5 of 360. Alright, now 1/5 of 360 divided by 5 is 72 degrees. That means that this angle here will be 36 degrees, and the reason for that is angles at a point. So I'm just going to put a wee mark there and say angles at point equal 360. Okay, that's why I got that angle there. Now what I'm going to do is I'm going to have a go at calculating the total height from there to there. I'll call that x at the moment, for want of a better letter. Okay, now we have a right angled triangle with an angle and a side length and an unknown. So this is definitely calling for SOHCAHTOA toa. I have a hypotenuse, I have a opposite, and I have an adjacent, and we're going to use tan to find that. So remembering that tan of an angle equals the opposite over the adjacent, I can say that tan 36 equals the opposite, which is 14 over unknown, and by the time I move that to there and that to there, I can rewrite that as x equals 14 over tan 36. Now you could have done that a wee bit faster if you had used the TOA triangle and covered up the adjacent side which you were looking for, and that would give you opposite over tan of 36 anyway, which is what we got. So that means that the height from the very bottom of this pentagon to the center of that circle is equal to 14 divided by tan 36, and that's 19.27 centimeters. 19.27 centimeters. Now, the bit that I'm interested in is this bit here, because it's the shaded bit. All right. So if I look at just the shaded bit, so this is the big triangle, and this is the small shaded triangle. All right. Now, what have I got? I have a triangle which is five centimeters less high than that because of this gap here. So that makes this 14.27 centimeters. We still have an angle of 36 degrees. And what I'm interested in is this width here. All right, which is there. I'm going to call that letter Y. All right, now again, now that I've got this here, I might as well use it. We have the opposite and we have the adjacent. I'm looking for the opposite, so it is tan of the angle times the adjacent. So Y equals tan of the angle 36 times the adjacent of 14.27. Okay. So I'm just going to minus my 5 there. There's my 14.27, nice and accurate. And I'm going to times that by 1036 equals, and I get 10.36. So y equals 10.37 by the time I round it, centimetres. Right, now I'm interested in the area of the whole of that small triangle. I know the height from there to there is 14.27, and I know the base is double of what y was. So if I take that 10.36 and I double it times by 2, I get 20.73. So the 20.73 centimetres is the base. And the formula for the area of a small triangle, so the area for a triangle is equal to half times base times height. So half times that number divided by 2 times the 14.27 equals 147.94 centimetres, 147.94 centimetres squares. I need 5 of them because there are 5 triangles making the pentagon. So this 5 times 147.94 gives us the area of the pentagon there, which is times 5, 739.7 centimetres squares.